Right. Prime numbers. What is a prime number? A prime number is any number that's only divisible by itself and 1. I'll give you an example. So the number 11 is a prime number because you can only divide 11 by 1 and itself, 11, to get a whole number. Yeah, you can't divide 11 by 2 to get a whole number or 11 by 3 to get a whole number. No, it only has two factors, which are itself and 1. Another example of a prime number is 13, only divisible by 1 and 13. So 6 is not a prime number. It is not a prime number because as well as being divisible by 1 and itself, you can also divide 6 by 2 and 3. Yeah, so 6 is not a prime number. Now tip, the first few prime numbers, if you want to check if they are prime, so for instance, let's say we want to check if 49 is prime, we can divide it by 2, 3, 5 or 7. If you can't divide it by any of these, there's a high chance that is not prime. As you can see here, 49 is divisible by 7, so this one is not prime. Let's say we had 53. Can't divide it by 2 because it's not even. Can you divide it by 3? No, there's a remainder. Can't divide it by 5 because it doesn't end in the 5 or 0. Can you divide it by 7? 6, 7 times remainder 4. No. But double check because this doesn't always work, but it's just a good tip just to narrow down if potentially it is prime or not. The first three prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and that list will continue. Yeah, there are infinitely many prime numbers. 1 is not prime because 1 is only divisible by 1. It doesn't have two numbers that is divisible by. Now, prime numbers are useful when dealing with prime factors. And prime factors are also useful when trying to find the lowest common multiple and highest common factor, which we'll go through in our next video. However, when dealing with prime factors, what we're doing when we're trying to find prime factors, we're trying to find the factors of a number that are all prime. So it'll make a bit more sense when I go through. So let's say 42. We want to find the prime factors of 42. We're trying to write 42 as a product of prime numbers. So how do we do that? We're going to use a factor tree. So what are two numbers that multiply together to give 42? 6 and 7. Now when you're doing this, anytime you find a prime number, you circle it and you stop. So which of these is prime? 7. So we're going to circle it and we're going to stop. Is 6 prime? No. So we're going to continue again. What two numbers multiply to give 6? 2 and 3. And these are both prime, so we stop here. Now, to write 42 as a product of its prime factors, we just multiply all the prime numbers that we found at the end of the factor tree. So for 42 it will be 2 times 3 times 7. And that will be 42 as a product of its prime factors. Let's have a go at 150. Two numbers that multiply to give 150, 15 and 10. Are either of these prime? No, so we can continue again. Two numbers that multiply to give 15, 3 and 5. Now we have two prime numbers, so we're going to stop here. What are two numbers that multiply to give 10, 2 and 5? And once again on this side we have two prime numbers, so we're going to stop here. Now we're going to write 150 as a product of its prime factors, and we get 2 times 3 times 5 times 5. This can also be written as 2 times 3 times 5 squared, as we have two 5s. Last but not least, let's have a go at 132. Two numbers that multiply to give 132, what we can see is even, so we're going to go with 2 and what's 2 divided by 132? 6 remainder 1, 66. Now, two numbers that multiply to give 66. because 2 is prime, so we're going to stop here, come here. 2 numbers that multiply to give 66, 11 and 6. 11 is prime, so we're going to circle that and stop there. Is 6 prime? No, so we're going to continue. 2 numbers that multiply to give 6, 2 and 3, and these are both prime. They are normal trees, so these are the prime factors of 132. So to write this out, we'll have 2 times 2 times 3 times 11, which can also be written as 2 squared times 3 times 11, like so.